So the first lesson from this chapter on generalized permutations and combinations are going to be permutations with repetition. And when we talk about repetition, what we're talking about is that we're looking to order a set of objects and different objects, and we can in fact utilize each object more than once. All right, so each object could be utilized more than once, and so consequently that changes how we do our counting. It's going to change things from a particular perspective, and we're still going to be using the product rule, but our counting is going to be a little bit different. So like, let's say, for example, how many strings of length 8 can be formed from the uppercase letters of the English alphabet? Okay, so we've got 8 letters. And now we're looking at the English alphabet, uppercase letters from the English alphabet. So consequently, for the first letter, we have 26. Now, the thing is that we're not told that we can only use one of the letters once. So consequently, that means that for the second letter, we can also use 26. And for the third, we'll get 26. The fourth, 26. Fifth, 26. Sixth, 26. Seventh, 26. And eighth, 26. Utilizing the product rule, we're going to multiply each one of them together. And what we'll get is we'll get 26 to the 8th power. Okay? So basically, we're taking the number of uppercase letters, and we're going to take it to the power of whatever, however long the string is. Okay? And that's actually going to be how we think about the more generalized theorem that we're going to work with here when we work with repetition. So here's our theorem. And you could have guessed it a little bit. The number of R permutations, and an R permutation is a permutation of length R, okay, of a set of n objects with repetitions is n to the R. Great, right? N being the size of whatever the set is that you're looking at, R being however long that string is that we're going to look at. So for example, if we say how many ways are there to assign 3 jobs to 5 employees, if each employee can be given more than one job, okay, then we think about we've got these 3 jobs, 1, 2, 3, okay? And for the first job, so this is job 1, we can have 5 employees. Now here's the thing. For the second job, we could give it to the same employee. So for job 2, there's actually 5 employees. And for job 3, same deal. That first employee could be given all 3 jobs, either lucky him or unlucky him. 5 times 5 times 5, that's 125. Or 5 cubed. So the string is of length 3, right? And the set is of size 5, 5 to the third, and that's actually how we count the total number inside of problems like this. So these are permutations where we utilize repetition. And that ends this mini lecture.